Here we're going to look at the pseudocode required for adding items into a linked list. And the first thing to point out is that this time we're going to be using the free pointer. We haven't really talked about this before, but just to sort of reiterate or recap very quickly, the first part of the linked list here shows you the nodes which actually contain values. The second part of the linked list shows you the free nodes linked list, as I mentioned in an earlier video. What we're going to do is we're going to make use of the free nodes linked list to introduce a new item into the linked list, and then we're going to change the pointers so that it fits in the correct location in the linked list. So let's start our code. So internode takes in a parameter, takes in a new data item, which is just a character that we're going to add to the linked list. So for example, it could be X or something. The first thing we do is we check that the free pointer, which is currently 5, is not the null pointer. Okay, and if that is true, i.e. free pointer is not the null pointer, then we can continue to insert the node into our linked list. If free pointer is null pointer, there's no space for us. So we set the variable index to be equal to the free pointer. We then set the array element index of the array mylist, its data item, which is within the node record. We set that to be equal to the value that's been passed in to the procedure. So we set it equal to the new data item. Okay, so in this example, it would add the new data item in the box here. And then the third thing we do is we change the free list pointer, because that's now got a value. So the free list pointer should be a pointer to the next empty node. And so the 5 will change to 6, which is the pointer from my list index. That's the first step in adding an item into a linked list. At the moment, it's just the end of our linked list, which is fine, unless we want to place it at a certain location within the existing linked list. If that's the case, we have to change the red pointer numbers so that the nodes can be traversed through in the correct order. Let's say we were looking to put the node after the node that has the letter E in it. So it will be HE, and then let's say we've got X. To make sure that we put it in the correct place, what I would do is I would find the node, okay, because this is an unordered linked list, it's not an ordered linked list. And so we'll find the node, we'll find the first occurrence of E, and then we'll link E to the new node. Okay, let me just draw this in so that we can keep track. Okay, so we've now got X in as our new node, our inserted node, but we want to link, we want to find where E is, we want to take the pointer that E is pointing to next, but we want to change it to where X currently is. So in this example, this line we're storing previous pointer, we're setting it to the result of calling find node with the letter E as our target. Now this is hard-coded, you're going to have to change this or adapt it in your own programs, obviously, but it's just showing you a specific example. And so using the find node E, I'll return a pointer to the node with the letter E, which will give us the number 1, okay, in previous pointer. And then we can then use that to follow the pointer to the next node at the present, which is linking to the first letter L. What we're going to do here is we're going to set my list index to the pointer of that to be equal to the pointer from the previous one, so where E was essentially. So we take what was 6 and we change it to 2, like so. Then we set the previous pointer's pointer, so where E is, instead of being 2, we want to set it to what index is. Index was the original free pointer before it got changed, so it's pointing to 5, and so the 2 underneath E becomes 5. And now if we ran through and outputted all the nodes, we would get something like this. Now, I don't know if you noticed the deliberate mistake there. Actually, it was a non-deliberate mistake, but what happened was we should have changed the pointer that was after the final letter in the original linked list. It shouldn't be pointing to 5, because 5 is the start of the free pointer list. It should have been a null pointer. Without that null pointer, we would have entered an infinite loop where you would have had HEXLLO, XLLO, XLLO, and so on and so on. So it's really important that you have that -1 at the end of your value linked list. Remember, there's a valued linked list or a normal linked list, and there is a free node linked list. And you need to have a null pointer for each of those to make sure it works. If you don't believe me, try it and see your program enter an infinite loop. I'm just going to finish off the program now by ending the if and ending the procedure, and that's all you need to know for adding an item into an unordered linked list.